In this series on drawing 2D details, we're now going to look at how to create a suspended timber frame floor, concrete raft slab. This detail is sort of semi-finished, it's not quite there. At the moment, we're not going to worry about finishing it all off because we just want to work on the main structural elements. So we're going to copy this entirely. I don't want to edit or destroy what we've got. We'll come back and change it later. So I'm going to move it across my page 10 meters. I could also just copy this and paste this into a new drawing. Sometimes that's what I'll do. Create, at least in ArchiCAD, create a new independent detail rather than move it across the page. Just to keep it all simple for now, we'll just move it. So the simple reality, again, I want to explain this in terms of practical life, is that we're moving the ground down, or we're moving the building in its relationship to the ground up. So in real life, of course, we could say that the building is moving up, but in terms of practical drawing, so that most of it's contained and remaining similar, we'll move that down. To make this even easier again, what I could also do is to grab the pier and the footing and the concrete slab and move it down. And we'll move this down approximately a meter. Now, the reality is we don't need a slab. It's just a pier. So I'm going to extend this just to get rid of these bits. Extend that to get rid of that. And then we've got a lump of concrete, right? So this is indicative of what the strip footing looks like. The strip footing will normally be sitting at around about ground level. The size of the footing is going to be dependent on what the engineer wants. At the moment it's 422, 400. Yeah, let's make it 400 by 400. And of course, it's probable that the ground would actually not be flat. Because we're doing a suspended timber frame floor, normally this would suggest that the ground is actually sloping. Now, we may have a pier underneath this strip footing. We may not. It's not very common that we would have piers underneath the footings, but again, the engineer may require that. So that's what we're going to show at the moment. We also are going to have a continuous subfloor wall, and so therefore there is going to be a bit of load placed on it, and we don't want any movement. It's not just an isolated pier. This is a continuous strip footing, just for clarification. Now, this also means that we've got our bricks running all the way down. We may still want to have our weep hole up here, and then we're just going to copy these bricks down as we did before. So that'll be multiplied by 86 millimeters, and we can just copy those down all the way down. And of course, the reality is that I don't want to have a chopped brick, so the size, or the position, I should say, of the ground to the building will actually be like this. And again, of course, it's the other way around. And so we'd be positioning the footing in the earth, wherever it needs to go, and then we'd be positioning bricks running up as necessary, and that would determine the heights of the other elements of the floor. Now, we don't necessarily need to have an exact relationship between the brick and the floor level, as we see here. This is dependent on a few other aspects that we're going to have a look at soon. Now, we don't have this foam, we don't have this sand, we don't have this gravel, and we don't have this polythene membrane anymore. We generally also don't have a polythene membrane underneath a strip footing. Normally in this circumstance, this would just be pouring concrete straight into the ground. It's possible, but it's not common. This is also going to potentially need to change a bit, but we'll play with that a little bit later. What we may want to have is we may want to have a damp-proof course between the concrete and the brick wall, or partly up the brick wall, or maybe further up here. And that's to stop moisture, damp, from rising up through the ground and up into the bricks. Now, again, we could achieve this also by putting a membrane underneath that strip footing. Again, it's just not very common. All right, next, we have a brick pier that's not a continuation of the wall. Another way of saying that, it's not continuous. It's an engaged pier that we're going to see in elevation, but we're not going to be seeing in section. And so that's a brick. So we'll start with a brick and we'll represent where this goes. And so it's the same height as this brick in section. And it's in this case, it's a full length. So it's 230 millimeters long, and it needs to move away 10 millimeters from here. And what we're seeing in elevation is that there'd be a mortar joint. Now, this is a little bit tricky if I want to go to this level of detail. The mortar joint is continuous, and it can still have a raked outer edge. The line should be thinner because it's in elevation, not in section. And this brick isn't going to be seen with these diagonal lines. In this case, it's going to look like a brick should look in elevation. And so we could also change this to be sand and look something like that. So that might be a brick. What I'll commonly also do is change the color or change the intensity of the brick. So of course I can't do that in this case. So what I'll do instead is I could select all of these, and I could do this in one go to make life a bit simpler. So find and select, pick up the setting of that fill, add. I need to find some other way of differentiating between these elements. So I'm going to use fill, add. It's going to find my fill type, and then I can select all of those bricks and change that to a darker orange. The reason why I want to do that is because I want to show that these are in section and this brick is in elevation. Now, to do this properly, I need to go move, multiply, 86, just like before. Now, it's not going to go all the way up to the floor, and I'm not exactly sure where it's going to go up to at the moment. I'll explain that a bit later. So I'm just going to stop a little bit short. And that's also not quite right, because we usually won't want to have the bricks being full length all the way. Why? Because we want the bricks to be stacked. So what's actually going to happen is that we'll have a brick, and then we'll copy this up again. So up 86, but this is actually going to be two bricks side by side. So 110, 110. I'll split this brick. And that's what we're repeating. We're repeating this pattern where we've got the bricks bonded together. Multiply. Now it's not 86 anymore, is it? It's 2 times 86. 86 times 2, 172. And so we can see that that brick pattern is repeating. And then I need to, if I want to do this really well, fill all of this gap with this mortar. So to do that, I can close the outside edge and close the outside edge. I can select this one. I can go add to polygon, magic wand, click, and that's going to add it to the gaps. Unfortunately, it's also adding it to over the bricks here. So to get rid of this, again, this is an ArchiCAD thing, select the fill, hold down magic wand, and I'm now subtracting it from those extra bricks that I unfortunately added it to. And that's it. That's good. It's working pretty well. All right, so now we've got our brick in section, our brick in elevation. This is our engaged pier. And now we need to start adding timber. We were using a structural piece of timber, or in this case, we're suggesting that it's pine, radiata pine, for our stud. For our bearers and joists, we're going to do something a little bit different. Right now, I'm going to change this. Instead of being tile and mortar, or I might leave that, but underneath this, I need to add something else. So I'm going to add a Hebel power floor underneath this. The Hebel power floor, we could use something like that. So I'm just going to draw it at the moment. When I represent this, it's 75 mil thick. What is it? It's AAC, so autoclave aerated cement, which means it's a lightweight concrete. So I could try to find something that looks like a lightweight concrete. I also have a different fill that I've made that's called AAC. And that's what that looks like. And I could also represent this as being reinforced, which it is. So I can go to my double dash line and draw a line through here. And that's a fairly decent way of representing this AAC. Now I could change the scale of this particular fill so it's a bit smaller. That probably looks a little bit better. All right. Underneath my power panel, so this is my structural floor sheeting, we could call it. It's a panel, not really a sheet, but same sort of idea. We then have the joist. What am I going to use for the joist? I'm going to create the joist out of an LVL. So in my settings, AD LVL. What is the LVL? It's timber. It's an engineered timber. So I'll use, again, a brown fill as the base and the thin black pen. I'm then going to draw it. So for this particular LVL, it's going to be 45 millimeters wide, and it's going to be 150 millimeters deep. Now, before I started this, we were talking about what depth of joists, what spacing of joists, what depth of bearers, what spacing of bearers. And so what we're doing here is we're using span tables provided by Carter, Holt and Harvey for their future build LVLs. I'm not including this in the tutorial just to keep it all focused on drafting, but this is where we're getting the information from. So we've got an LVL, in this case in section, that's the floor joist, and then we've got an LVL in elevation, so that's going to look like this, which is spanning the other direction. And it also is going to be 150. It's going to be thicker. It's going to be a 75 millimeter thick bearer, whereas this was a 45 millimeter joist. Now, because the bearer is in elevation, not in section, it's also a thinner line. Same with the brick idea here. So I might need to make this simple. So again, let's turn that back on. All of these bricks should have a thick outline because they're in section. Where these bricks, let's make that go back. Whereas these bricks have a thin outside line because it's in elevation. This piece of timber needs to have a thick outline because it's in section, whereas this bearer needs to have a thin line because it's in elevation. Again, same sort of thing. Anything's in section needs to have a thick outline. And the way that I would normally suggest it is the more important it is, or the more structural it is, the thicker the line should be, as long as it still makes sense. All right. Now, we'll move these into place. So where do these sit? The idea is that the joist goes directly underneath the AAC flooring, the Hebel flooring. And of course, we may want to have more of these joists. So move, multiply, spread, 600 millimeters. So I can start to space those out. Now, before I do that, I'd normally also want to have a double joist at the end. So I might just stretch these out a bit, just so these are disappearing into nothing. So before I start to do my spacing, I'm probably also going to go drag a copy and do a double joist on the end. And then I'll start to multiply from there. 600. So remember, when we're talking about centers, we're talking 600 from the center to the center. So if I therefore measure from the right to the right, or the left to the left, that's where I get the 600 from. And this bearer is going to span through continuously. So these joists span continuously over the bearer, and then this bearer needs to span continuously over the engaged pier, and then isolated pier, and then isolated pier, all the way through to the other side of the building, hopefully, where we've got another engaged pier. And of course, if I can't get the bearer to span that far, it's okay if it spans at least between 3 elements, 3 piers, and that would allow for a continuous span. If it's only spanning between 2 elements, that would be a single span, and therefore it wouldn't be able to span as far. Now we see that this is a little bit of a weird, awkward relationship. I want the bearer to be sitting on the brick, not this, again, weird relationship. So I'll get rid of the ones that don't work. And again, this is still a little bit weird, but the simple reality is, how did we get to this point? Of course, the point is that we don't need, again, like I was saying, to have a relationship between the outside brick and the relationship with the floor. So in reality, what we can do here is to move this element up. I might just need to split this. It's going to be a bit strange because it's an object, but it'll work. We're going to move this up. So I want all of this to be sitting on top of the brick. Now, it's not actually exactly sitting on top of the brick. I'm still missing an element. So I'm going to group this all together and move it up just another couple of millimeters. In order to stop termites from getting into our house, right? Termites don't really care about the bricks, but termites do want to get into the timbers. They want to get into the bearers and the joists and the framing and all the rest of it. I need to either physically stop the termites or make it so I can see when termites are trying to get into the building. So in order to do that, I want to have an ant cap. So I'm going to use a fill to represent that. So that can be the empty fill or solid fill, doesn't really matter. Sometimes I might make this a light gray color because it's generally galvanized, so it looks silver. What this is going to do is extend past the edge and down. Let's make that 30. And then it's going to extend away at a 45-degree angle. I might make this slightly lighter. And now the idea of this ant cap is not that it's going to stop termites. It's got this sticking out bit of metal. And the idea is that the termites could still climb over this, but the point is we're going to see them doing it. So even if they were to be able to get past the ant cap and to the timber, we'd be able to see that happening. Now, hopefully they can't do it. Hopefully they're not going to want to do it. But the idea is that if we inspect a subfloor, and this is, of course, one of the biggest issues with subfloors, we need to inspect them. If we regularly inspect it or get a pest person to inspect them, then we're going to see the line of termites going from the brick up to the timber. Because the problem is that they could crawl through the middle of this brick pier and we'd never see them. Or they could crawl between the gaps between this brick and this brick into the timber and we'd never see them. So the idea of the ant cap, and of course the ant cap needs to go all the way to here, is that we're going to be able to see it happen if it's happening. We also need to tie down, and so we need to stop all of these timbers or this house from flying away, and so we're going to have a tie down bolt. So this might be coming through here. We're going to be screwing the Hebel into the joists, and we're going to be screwing or using a plate fix to connect the joists into the bearers. We don't want them sliding around as well. So we might use a bracket, we might use a screw or screws, or we might use both. And now we've got a pretty good understanding and relationship of how our timber frame floor works. And so we've got our flooring. In this case, it's floor framing, joists and bearers, but we're using a Hebel power panel, autoclave aerated concrete, not timber flooring. But of course, it's just a substitution, a similar sort of thing. It's doing a similar sort of job. We could also use compressed fiber cement as well. And so whether this is a bathroom or whether this is a bedroom or a living space, it doesn't really matter at the moment in terms of how it's currently set up. Now, in this case, I could change the way this works and change this brick to be my weep hole. And have my damp proof course running down here. I could also have this up at ground level, and I may also have this higher up as well. I may have this up underneath windows in addition. So weep holes up there. The idea is I want to get all moisture out of this building as readily as possible. I may also have ventilation. I probably will have some type of ventilation down here as well. Subfloor ventilation. I'm not going to represent this at the moment. But the idea is I need to ventilate this space because I can't have it building up with moisture because I've got exposed timbers. Now, is this sufficiently insulated? Probably not, right? I've got an open bearer, I've got an open joist, and the only insulation that I've currently got is the insulation that's created by this Hebel power floor. Now, a Hebel power floor is a bit more insulated than some other building materials, but it's still not fantastic. So I probably also want to add insulation as well. So I can use a couple of different types. I could use a foam board, or I could use this. So I could use a bat with a blanket on the underside of it. So let's move this first. I'm going to stretch it so it's the size of the depth of the joist, 150, and I'm going to add a line around the outside of it as an object. And I'm going to make that line thick. And I need to make that line dashed. And that's the actual insulation. All right. Now I'll just add this line manually just to make this simple so you can see what I'm trying to do. And so here what we're showing is that there's a line, so fabric on the underside of this insulation blanket, and because I don't want animals to get up into the insulation. And so I might be having small panels in between, or I may be actually having this lower than and fixing to the underside of the joist. At the moment, I'll just leave it like this, shown going between the joists. I'll just repeat that, just so it's consistent. So we'll copy that across, so it's over there as well. And now this is pretty good. It's not perfect yet, but it's a pretty good representation of a timber frame floor, a traditional timber frame floor. But of course, in this case, we're using Hebel power floor and LVLs for bearers and joists. Whereas traditionally, it's probably all made out of hardwood.